All right, so we're going to try a question here. Log x base 5 is equal to negative 3. The question is determine the value of x. So all we really have to do is rearrange this into exponential form and we'll be able to do that. So our base is going to be 5. Our exponent is going to be negative 3. And then we're going to say that's equal to x. Because all we did was rearrange, right? Our base goes down to be the base. Our 1 by itself on the side of the equation is our exponent, and the 1 inside the log is out by itself. So all we have to do is say x is equal to 1 over 5 cubed, which is just equal to 1 over, and 5 cubed is 125. So then x is equal to 1 over 125. So we're going to try graphing a logarithmic function. And so the first thing you need to do is type it into your graphing software. Now to graph this, I actually had to go into functions, and then I had to go into another function bar to find it was log with a little a underneath, so that you can actually put the base in, because if you just put in log, it doesn't give you an option to put in the base, because it just gives you log base 10 as a standard. So you need to find something that says log and then has a little letter underneath so that you can actually put in the base to graph it in the software. Now what we're going to do first is we're going to do these questions. So once you've graphed it, I would pause the video and graph it. We'll get going on these questions. So let's find the equation of the asymptote. So the equation of the asymptote is actually just this stuff. It's the stuff that's inside the brackets. So it'd be x plus 9, and you set that equal to 0. So the asymptote is actually going to be x. So x is going to be equal to, and if we were to move the 9 over to the other side, we're going to get negative 9. So x is going to equal negative 9, and that is the equation of the asymptote. So all you do is take the stuff that's inside the brackets here. Okay, we ignore the base, we just take what's inside the brackets, set it equal to 0, and solve for x. And that gives us the equation of the asymptote. Okay, the domain and range. So let's do the domain first. So we're going to write x. So if you look here, it goes right up to the asymptotes. The asymptote is this line right here. X is equal to negative 9. So it goes up and just almost touches the line negative 9. X is equal to negative 9, but it never actually touches it. So we're going to end up with x is greater than negative 9, and then x is contained in real numbers for our domain. Now our range is actually just going to be y is contained in real numbers. And that is because it goes up infinitely and it goes down infinitely. And since it does that, we just write y is contained in real numbers because it covers all real numbers. So let's find the y-intercept. So the y-intercept is going to be just where x is equal to 0. Right? It's always the same. We can always just set x equal to 0 and solve for it. So let's do that. Let's use our equation here. Y is equal to log base 3 x plus 9 plus 2. So we're going to set our x equal to 0. So we're going to have y is equal to log base 3 0 plus 9 plus 2, which is just equal to log base 3 of 9 plus 2. Okay, so we can actually just calculate this in our calculators, and what we're going to end up with is that is equal to 4, right? Because we can just put log with a base of 3 and an entry of 9, and then just add 2, and we're going to end up with 4. So y is equal to 4 is the y-intercept. Okay, so the y-intercept is 4. And last but not least, the x-intercept. So the point where it intercepts the x line is just going to be y is equal to 0, right? Because when it intercepts the x-axis, y has to be 0. So what we're going to do is set our equation equal to 0. So we're going to say y is equal to log of base 3, x plus 9 plus 2, and we're going to set that all equal to 0. So we're going to say 0 is equal to log base 3, x plus 9 plus 2. So the first thing I'm going to do is move the 2 over to the other side. So we're going to end up with negative 2 is equal to log base 3 times x plus 9. Now what we can do, and I'm just going to scroll down to give us some extra room, is we can rearrange this into exponential form. So we're going to say 3 to the exponent negative 2 is equal to x plus 9. And as you can see from here, this is going to be fairly easy to solve because we can just say 1 over 3 squared is 9 is equal to x plus 9. We're going to get the x by itself, so we're going to say x is equal to 1/9 minus 9, which just ends up being negative 80 over 9 if you work out the math. So our x-intercept is going to be negative 80 over 9. So that's approximately equal to negative 8.9. So that is going to be the point on our graph. And let's take a look here. So our line is almost reaching negative 9 at this point. So negative 8.9 makes sense as an x-intercept.